Welcome to my 6-inch 6S Alien build. This is the 6-inch Alien frame kit, which I'll be dissecting in just a minute. Before I do, some of the other major components I'll be using. These are the Lumenier 2206 2000 kV motors. So on 6S they'll have a theoretical maximum RPM of around 48 to 50,000, plenty quick enough. From my tests on these motors using 4S on 5.5 and 6-inch props, I was easily able to exceed 1,000 grams of thrust. In fact, on 4S they produced about 1,200 grams of thrust using these 60-45 HQ tries. So they'll be the motors used in the build. ESCs. Unfortunately, I haven't received my 30 amp Kiss ESCs yet, so I'll be going with these 30 amp little Bs. These are rated for 6S, and so looking forward to giving them a try on this build. I've used plenty of the 20 amp little Bs, but this will be the first build I've done using the 30 amp little Bs. The flight controller for this one will be the Kiss flight controller, which I'm very much looking forward to trying. Receiver will be what's now common for all of my builds, the FreeSky X4R S-Bus receiver. I'll pull the cardboard off and de-pin it. I do have some of the naked ones coming, but these are all I've got at the moment, so I'll be stripping that down, de-pinning, removing cardboard and shrink wrapping. FPV gear. So first of all, the camera. This is read the box here, the Foxeer XAT600M Sony HS1177 camera with a top connector on it. So it is possible to order this camera with a bottom connector, which I think is the typical default, or with a top connector. So if you're building an Alien, make sure you get one with the connector at the top, because it's not possible to invert the image, and with the connector at the bottom it interferes on the frame when you tilt the camera back. The VTX I'll probably use with this will be one of these AMWay. They're super lightweight. Unfortunately they've still got the dip switches on them, but they are very good quality and never had any issues with them. Piggy tail is necessary for the VTX to frame mount, I think, for the Alien to make the most of the build. So I've got one of those there. Top it all off with one of these video aerial systems or VAS Duraspec antennas. This is a green one because it's a left-hand circular polarization, which is what I prefer to use. This is the 6-inch Alien frame kit. A few things. It comes with 2 top plates here. One of the top plates makes it easier to attach a GoPro camera, and then for some reason you get a spare one, which doesn't have the same cutout on it, but for the way I attach my camera, it just means I end up with a spare plate if I break one. The lower frame plate, the arms, a flat file and round file, which make it easy to file off the sharp edges of the frame. These antenna straws for the receiver, which are flexible but not brittle, relatively stiff as well. I do like them. A few other bits and pieces here. The PDB, which is an integrated part of the frame, so it's necessary to use their PDB for the structural integrity of the frame. It comes with an XT60 that's designed to solder direct onto the PDB, but I find that it can get damaged quite easily, and so I prefer to still run a pigtail on the end with an XT60 rather than direct mounting to the PDB. And of course the signature Alien purple anodized aluminium hardware kit, which is phenomenally light for the amount of hardware that's in there. Now, carbon fibre dust is not good for your health. It's not necessarily carcinogenic, but like any dust, probably try and avoid breathing it in. So I do this in the sink under running water using the supplied file. First thing I want to focus on is the top plate. and I'll do all of the edges quickly, but particularly the edge where the battery strap is going to wrap around the frame for both the battery and my high def camera that I run on the top. It's much easier to do this now while the frame is apart, and carbon fibre dust is also conductive, so it's not something we want around the microelectronics like flight controllers. With the top and bottom plates done, it's now the arms. I'm only going to take the sharp edges off of the arm, where it protrudes from the frame. So the inner part of the arm, where they interlock together, and where they're held by the top and bottom, or the PDB and the base plate, I want to maintain the square edges on those for maximum integrity or strength. So it's only going to be the outer part that I'll take the edges off. Now I want to solder the motor wires direct to the ESC, so I'm going to start by cutting the existing heat shrink off with a very, very sharp knife. Take a bit of tape and just to help hold that down. Now it seems counterintuitive, but putting some solder on to desolder makes sense with this factory stuff. It's got no lead in it typically, so extra solder on your soldering iron helps transfer the heat. I have my soldering iron turned up to about 400 degrees Celsius, which is fairly hot. Try and make it quick and hot rather than slow and hot to remove these wires. And then I'll just replenish a little bit of the solder with some of this stuff. Part of the PDB preparation is installing these captive nuts, which involves playing Where's Wally with the hardware kit to find this single screw and washer that's used for the process. Basically just pulls them down tight. I've temporarily attached a motor to the arm here, and then temporarily attached the arm to the base plate with the PDB on top, so that I can work out the optimum position for the ESC, so I can go ahead and cut these motor wires. So a few things: this PDB has got little white dots next to the solder pads that will end up being positive. So for this ESC it will be wired straight with the red and black wires coming up to their respective solder pads. 10 to 15 millimeter gap here is ideal, and with that in mind I can go ahead and cut these motor wires to length now, and then I'll measure the motor wire length that I cut and do exactly the same on the other three. The motor wires are now soldered to the ESCs, and you'll notice that they're all soldered straight through. I haven't crossed any of the motor wires like we used to, because I'll use BL Heli Suite to reverse the motor direction for the two that need it. Last step now is just to put these last two bits of heat shrink on these final ESCs. And to attach the motors, I use a little bit of this blue Loctite on each of the screws. With the four motors now securely attached to the arms, along with their ESCs, I've attached the arms to the base plate, or sandwiched them between the base plate and the PDB. The kit comes with some high tensile screws for attaching in the inner and outer hole of each arm, as well as aluminium anodized ones. I've used the high tensile ones. I think the extra bit of weight is worth it for the extra strength that they'll provide. In the centre hole for each arm here, I've used the aluminium, anodized aluminium screws, and because those center ones just screw into these nylon standoffs, so they don't actually offer any structural purpose except to support the flight controller. I've cut the ESC power wires to length and soldered them on to the PDB. I've also attached the XT60 to the PDB. I was originally going to use a pigtail to the XT60, but I've now got an XT90 on the way which I want to test. So I'm going to put the XT90 on a pigtail soldered to one of these pads and leave the XT60 on there so that I can swap out batteries with either XT60 or XT90 and just do some comparisons. The front of the quad is going to be this side, a little arrow to indicate that here, but it's because this has the slots for the camera bracket in the front, which means that I've mounted the PDB with the XT60 on the right, being right-handed. That makes sense to me. These nylon standoffs, I've got little rubber O-rings, tiny little rubber O-rings that come as part of a kit called the Plumbr kit from a different supplier, and they go on there. The Kiss flight controller, I've drilled the holes out from 3mm to 4mm so that when I sit that on here, it has a little bit of slop in it, because with the O-rings on the bottom, I'll put some O-rings on top, and it will be the pressure on the O-rings, which just a slight bit of pressure that holds the flight controller in place, and hopefully those rubber O-rings will absorb any minor vibrations from the frame so they don't interfere with the flight controller. You'll notice then that the Kiss flight controller arrow points to the back of the quad, and I need to have it mounted this way so that my USB connector is on this side, but that's all okay because the Kiss GUI allows me to turn the flight controller around 180 degrees to mount it this way. I was originally going to solder the servo leads direct to the flight controller, which would have been the neatest and lightest approach to the build, and so I didn't worry about the extra length on here because it would have been cut off. But because I plan to now test some different BL heli settings on this quad, I want to be able to quickly remove the ESC servo leads so that I can reprogram them if necessary. So I've soldered header pins on here, and these will now connect. I don't know if this is the right one, but they'll now connect onto there, and I'll just have to find a way to tidy up the excess lead. If I'd thought of this in advance, I could have soldered or shortened the lead and soldered it back direct on the ESC and got rid of the excess, but that's what we'll have to live with going forward. To prepare the HS1177 camera, I've first removed the Phillips head screws from the back here. Then I take these tiny O-rings that come in the Alien kit and put them around the holes where the screws came out, and just help to hold the original plate in place. Then I take this little carbon fibre bracket that comes in the Alien kit and hold it over like so, and put two of these little Allen key screws back in place of where the Phillips head ones were. Now these are only screwing into plastic, and they've got a very fine thread on them, so don't need to do them up real tight. Next I'll take these little plastic brackets that come in the Alien kit and attach them so they're sitting out the back of the camera here, just using some of the smaller screws that are supplied with the kit. Once again, these are just screwing into plastic, so don't over tighten them. Now attach the side plates using first of all the screw that comes with the HS1177 kit, not in the Alien kit. It's a little Phillips head screw. And now take one of these screws that comes in the Alien kit, and you can put this screw in different places to change the camera angle. It's also possible to file this out so it's easier to slide it later on, but I'm just going to set it up at a position that's at about 3/4 camera angle, and being careful once again not to over tighten since I'm just screwing into plastic. And then repeat for the other side. Just sit it level on the bench to make sure the camera angle's even on both sides. And the camera is prepared. The bracket here that attaches, or the plate that attaches to the camera, does have a cutout here which allows for a bottom mount camera. As I said earlier, this is a top mount version, which is easier to use, I think. The bottom mount would come out here, but it has more chance of interfering with the base plate of the frame. But they do make it to suit both. To illustrate how I use the regulator and LC filter, here's my picture of a 6S battery outputting 25 volts to the input side of the D-Sun reg. That'll be adjusted to output 12 volts to the LC filter here, and then the LC filter will output that 12 volts split between the video transmitter and the camera here. And for the yellow wire that's part of the video connection, I don't have a yellow marker, so I'll just draw it in black here. Will just be connected directly between the camera and the video transmitter. To show how these components will be fitted, I'll be taking battery voltage from these two pads here into the input side of the D-Sun reg, which will live there under the flight controller wrapped in heat shrink. The output of the D-Sun reg will go to the LC filter, which will live here, and then the camera on top, and the video transmitter will be probably velcroed to the battery strap or mounted upside down on a plate on top of the flight controller. To make my power lead for the D-Sun regulator, I take this old bunch of cables that came with a Naze flight controller, and carefully using a scalpel lift up the tabs and move the wires to where I need them, a red on the outside and a black on the outside. I don't like to solder these small type wires directly to the PDB. On my 5-inch Alien I did this and the wires vibrated and eventually snapped off and I lost my video mid-flight. So now I solder some header pins onto the PDB, and then I'll take my modified servo lead cable, plug that in like this and rest that in position. Cut these cables to length and solder them to the D-Sun regulator. Before I put heat shrink on this D-Sun regulator, I need to set the output voltage because it's adjustable. So I've got it sitting on some piece of plastic here so it doesn't short circuit on the carbon fibre frame. I've got a 4S battery. I know I'll be using 6S to fly, but as long as this battery is greater than 12 volts, then the output voltage setting will stay the same. So plug this in and take the screwdriver ready, take the multimeter and check where it's at. So it's at 10 volts. So I'll just turn this little screw here. There we go. 12.03 volts, that's close enough. So with that set now, I can put the output wires on it and heat shrink it. The desun regulator is now wired up and it'll get hot glued down in about that position there. The flight controller will go over the top of it. Due to the header pins here for the ESC servo cables, I'm going to need to run this little LC filter on a slight angle to get the header pins, or to get the cables on that. I've put a pair of header pins on there. They've got a little solder bridge on the back, so that gives me a pair of outputs. One pair will be used for the video transmitter and camera, and the other pair for the flight controller. It will now get covered in heat shrink. I've temporarily removed the desun regulator and added an extra set of header pins onto the PDB here that get power from the battery. One pair will still be used for the desun regulator, and the other ones will then be used for the camera tuning cable earth lead, which I'll explain shortly. Here's the summary of the cabling for the camera and VTX. So from the LC filter there, I was originally going to have separate plugs for the VTX and camera power output. As it turns out, I need to use one of those outputs for something else, so I've combined the power and ground wires into one plug that feeds out to the camera and video transmitter. So for the video transmitter, I've used the factory cabling and cut out everything that's unnecessary. You can see the bigger plug there just has the yellow video wire in it. The other wires for power out and audio out have all been removed, and I'm just keeping the wires that I need. And then there's a separate plug there for the power into the VTX. On the camera side, I've taken one of these, a camera tuning cable that comes with the HS1177, taken one of those and cut it up and modified it to be my cabling on the camera side. So it has the small white plug with the 4 outputs, power from the LC filter plug, video to the video transmitter, and then this white wire which is coming down to a separate plug which will be mounted at the back of the quad, and where I can plug in the camera tuning remote. That plug also has a separate black ground wire running back to the PDB. So with that, I can plug in my modified camera tuning remote. It's had all the unnecessary plugs and wires chopped off of it, just leaving the white and black wires which align with the white and black wires on this plug here. So to give you an idea, that's the complete circuit that will be on this quad. Having the camera tuning remote separate and with a plug at the back allows me to change the camera settings without disconnecting the plug from the back of the camera and without removing the camera from the quad. I've combined the video transmitter and camera into one plug on there, and the other plug I have running in here is giving regulated power to the flight controller. Negative side of it, the ground side, will be where this cable will plug in first of all, and then the desun regulator on top of that. And that will basically complete the power circuit of the quad. This was my plug that will be mounted at the back here, where I can plug in the camera tuning remote to make camera adjustments. I've also put the header pins on the flight controller for the receiver, and I've taken my X4R receiver, stripped it down, pulled the cardboard off, depinned it, and I've just put a servo lead on there, and that will be my naked receiver, which will plug into the flight controller and be mounted to the top plate of the quad. The flight controller is mounted on here with its set of 4 O-rings underneath it and 4 O-rings above it. The little retaining nuts are here on top of the standoffs, and I only do them up with a small amount of tension. I don't want to squish the O-rings, I just want it to pull down a little bit firm on the board. The problem is that these are then very, very loose, and they're going to come off in flight within a few minutes. So I take a hot soldering iron and then just lay it across, and for a second or two, and effectively melt the top of the standoff to the nut, and that locks it in place. It can still be removed later, but that will prevent it from easily coming undone. Just do that to each of the 4 of them, and that will retain the flight controller. I'll be attaching the standoffs and screw hardware next. I've laid the standoffs out in line with their position on the baseboard, and on the left of each standoff is the screw that I'll use to attach from the bottom of the plate, and on the right of each standoff, as you're looking at it, is the screw I'll use from the top of the plate. So in the centre here, you'll notice on the right I've got little round head cap screws or button head cap screws. They will be on the top, and they're like that just to minimise any potential damage of puncturing a battery. On the top plate over here is the captive nut that will need to be attached to the top plate, along with the screw and washer or spacer that will hold the antenna bracket on. To insert the captive nut from the base, just align its jagged edge with the bottom of the hole, take our Where's Wally screw and washer and thread it through from the top. And just tighten it up, just watching that captive nut will pull up tight against the base plate. Remove Wally, and that's now prepared. Take the antenna straws and pass them through their respective holes, and then place the top plate in position. It's a little bit tricky, but then we put the spacer between, and this screw with a little bit of Loctite on it will go down through the hole and pull that plate down a little bit. Then there'll be additional spacers go in the other corners with the screws down into the standoffs on the back of the frame. I need to be able to pass these antenna wires up through the straws, but I want to be able to bend them first, so I'm just going to heat them up with the ends of them with a bit of a heat gun. Then I pass a large paper clip in and pull them round. The paper clip helps ensure that it becomes like a mandrel bend that doesn't close the hole up as I bend it. And with the straws pulled out to the sides a little bit, I can pass the pigtail sort of down the centre of them, but still be able to put these antenna wires around it up each side of them. I'll end up hot gluing the receiver in position there, and that top plate will be ready to attach. Before I install the video transmitter, I'll take a bit of this hook tape, hook velcro, and stick it to the face here, and it'll make sense when I pass the battery cable through. Effectively the battery cable loop side will hook on there, that'll wrap around the frame, and that will hold the video transmitter in position. The 6-inch 6S Alien build is now complete. I've calibrated the ESCs and set up the flight controller in the new Kiss GUI. Put the battery strap on and the rubber pad on top for the battery. Put some electrical tape to hold the ESCs to the arms, and if we look in there you can now see how the video transmitter is held on to the battery strap with the Velcro. When I pull that up tight, it creates a bit of clearance in there, the flight controller, and that'll hold that in place. Now ready to go to the field and start the tuning process. And left over from the build we have the round and flat file, the square carbon fibre plate, a spare carbon fibre top plate, some M5 nylock nuts. I use the ones that come with the motors to hold the props on, some spare nylon standoffs, spare M3 screws, all of the M3 nylocks. I use my own steel nylocks on top of the PDB, which screwed into the steel screws through the base plate, a spare spacer, and the Magic Where's Wally screw and washer.